So let's just start the commutative property under integers. First of all, we'll talk about the collection of integers, and the integers are nothing but represented by z, and the collection includes the number as, so goes on, -2, -1, 0, 1, 2, 3, and so goes on. So like we did before, that we have checked the commutative property on the whole numbers under the basic 4 operation. On the same sense, we'll check the commutative property on integers for all the basic 4 operations. So let's just start with the addition first. So let us suppose I will take any two particular integers from this particular collection. So let us suppose I'm taking -1 and 0. So as if I'm adding -1 and 0 in the different orders, means first of all I'm adding -1 and 0 in the sense that -1 is in the first position, 0 is in the second position, and if I will add 0 and 1 in the different order, means 0 first and -1 on the second place, the answer will be -1 plus 0 is nothing but -1 plus 0, and -1 plus 0 gives the result as -1. But in the second case, when I'm adding 0 and -1, it is nothing but 0 plus minus is nothing but minus. So it is plus minus -1. So 0 minus 1 is nothing but -1. And hence at the end, what will be the conclusion? The conclusion is whenever I am adding any two particular integers in the different order, means like a plus b or in the order b plus a, the answer is always same. The answer is always same. As from this particular example, this is all clear to us that whenever I'm taking any particular two integers and I am adding them in the different orders, means first of all we are taking -1 in the first place, and in the second example we are taking -1 at the second place. So a plus b is always is equal to b plus a. It means that the integers under addition is always commutative in nature. So what will be the conclusion? That addition is commutative in nature. So I hope this all clears to you. Take any particular example out of the collection of these integers, the answer will always remain the same, that is a plus b will always is equal to b plus a. So let's just start with the subtraction again. We'll take any particular two integers out of the collection of these integers. So let us suppose I will take 2 and 3. So when I'm taking 2 and 3 and I am subtracting 2 and 3 in the different orders, means on the first place I'm taking 2 at the first position, and in the second particular example I am taking 3 at the first place and 2 at the second place. The answer will be 2 minus 3. It will be 2 minus 3, and 2 minus 3 is nothing but minus of 1. Again, in this particular answer or in this particular question, 3 minus 2 is nothing but plus 1, because 3 is positive over here. So the answer is different. It means that a minus b is not equal to b minus a if a and b are any particular integers. So whenever I am taking any two integers out of the collection of these integers and I am subtracting them, then a minus b can never be equal to b minus a. So it means that the commutative property for the integers under the subtraction is not following, and hence subtraction is not commutative in nature. Why so? Because a minus b is not equal to b minus of a. So let's just start with the multiplication symbol now. Now again we'll take any two particular numbers out of the collection of these. Let us suppose I am talking about -1 and 3. So if I'll take -1 and 3, so let us suppose I'm taking -1 and 3. So we'll multiply -1 and 3 in the different orders. Means first of all I'm taking -1 at the first place, and for the second time I am taking 3 at the first place and -1 on the second place. So -1 into 3 is nothing but -1 into 3, and the answer will be minus of 3, because 1 into 3 is 3 and negative will be the same. And For the second answer, 3 into minus 1, it is nothing but 3 into minus 1. So 3 ones are 3 and negative will remain the same. So the answer is nothing but A into B is equal to B into A. As we can see over here that minus 1 into 3 or 3 into minus 1, both of them are giving the same answer as minus 3. So it means that we conclude that A into B is equal to B into A, and hence the commutative property follows under multiplication for any two integers A and B. As minus 1 is an integer, 3 is an integer, so at the end what will be the conclusion? That multiplicative is commutative in nature. Multiplication is commutative. Why so? Because A into B is equal to B into A for any two integers A and B. So let's just move on towards division. So let us suppose I will take another example of the division. For the case of division that I'm taking, let us suppose 3 and 2. So if I'll take 3 and 2, so we'll divide 2 and 3 in the different orders. Mean, first of all, we'll take 2 divide 3, and second time we'll switching the position of both of them as 3 divide by 2. So first of all, we know that 2 divide by 3 is nothing but 2 by 3, and 3 divide by 2 is nothing but 3 by 2. So is both of them or are both of them same? No, obviously 2 by 3 can never be equal to 3 by 2. So hence at the end what will be the conclusion? That A divided by B can never be equal to B divided by A because of this particular example. As we know that 2 divided by 3 is not equal to 2 divided by 3 divided by 2, because the answer of this is 2 by 3 and this is 3 by 2, and both of them, they are not equal to each other. So hence A divided by B can never be equal to B divided by A for any two integers A and B. So the commutative property does not follow over here. It means that division is not commutative in nature for the integers or for any two integers A and B. So I hope this all concept of the integers for the commutative property under the basic 4 operation is all clear to you, that the addition is commutative, the subtraction is not commutative, multiplication is commutative, but the division is not commutative for any two integers A and B.